There are times that a limit fails to exist. And if you recall, we have one-sided limits, where you're evaluating a limit but coming from one direction only. So for example, if you're coming from the right, a one-sided limit would look like this. So if I was coming from the right and I was approaching A, I would have a little plus sign next to the A to indicate that I was coming from the right, and then my limit, we'll call it L1. If I'm coming from the left, approaching A, then I would have a little negative sign indicating that I'm coming from the left. And I'll call that limit 2. Now a two-sided limit is when you're finding the limit coming from both directions, from the right and from the left. And when we're looking at a two-sided limit, we don't label it as coming from the right or the left. We just label it as x approaches A so that we know it's coming from both directions. Now this limit, the two-sided limit, will not exist unless both the right and the left-sided limits are equivalent. So this only exists if the right-sided limit is equal to the left-sided limit. So now, looking at this example, the limit as x approaches 0 of the sine of 1 over x, if we're doing this by looking at a graph, it's really, really hard to see what's going on as you're getting closer and closer to 0. So if you look at a table of values for sine of 1 over x, you'll notice that as x gets closer and closer to 0 from the left, these values here aren't approaching any particular number. It's bouncing back and forth all over the place. It's not getting closer and closer to one specific number. And the same thing happens here. If we're looking at it from the right, these values here are not approaching any single number. It's bouncing all over the place. Because the left-hand limit, there is none, and the right-hand limit, there is none. And then in addition to that, they're not equal to each other. We would say that the limit as x approaches 0 of sine of 1 over x, we would say that does not exist.